Hello and welcome back to Engineers Olympiad. We are starting new topic, that is hydrological and hydraulic design of bridges. Broadly speaking, we can categorize design of bridges into two parts. One is the hydraulic design, and second one is the structural design. In this design, we make an estimation about the amount of water that is going to come on that bridge site where we are proposing to construct a bridge over a river. Amount of water coming to the bridge site where we are proposing to construct the bridge over a river, and how that water will pass underneath the bridge, and how that water will pass underneath the bridge. And in structural design, we deal with planning and sizing various bridge components so that the structure is stable, it's durable, and most importantly, it is economical under all expected loads during its service life. All right? So broadly speaking, we can categorize the design of bridges into two parts, one being the hydraulic design and other being the structural design. In hydraulic design, we make estimation for the amount of water that is coming to the bridge site where we're proposing it to construct over a river, and how that water will pass underneath the bridge. And in structural design, we deal with planning and sizing the bridge components so that the structure is safe, it's stable, it's durable, and economical under all expected loads during its service life. All right. But the topic that we are starting is the hydrological and the hydraulic design of bridges. So we'll be dealing with that in this video lecture and all the upcoming video lectures. All right. So let me wrap it first. Let me rub it first. All right. Hydrological and the hydraulic design of bridge structures. So we can say that the design of a bridge across a river demands that detailed attention is to be paid not only to the route location, potential traffic flow, or the structural and foundational design, or the details, but also to the characteristics of the river beneath where we are proposing to construct a bridge. All right. So the most important thing is that we have to study about the characteristics of the river. And to evaluate the characteristics of a river, it's necessary to collect information on aspects such as channel stability, sediment discharge, scour, and other hydrodynamic forces. All right. So to evaluate the characteristics of the river beneath, we have to study about various aspects, one being the channel stability, sediment discharge, scour, and other hydrodynamic forces. So we can safely say that one of the essential data for the bridge design is the fair assessment of the maximum flow which could be expected to occur at a bridge site during the design period of the bridge. And that is the very basic essence of our topic and the hydraulic design of the bridges. All right. So let me rub it first. So very due attention needs to be paid to the characteristics of the river beneath before proceeding for the structural design of the bridge. We have to make fair assessment of all the characteristics of the river where we are proposing to construct a bridge before going for structural design of the bridges. All right. So let me take you through the hydrological and the hydraulic part of our design of bridges. Hydrological design. The hydrological design deals with estimation of flood discharge that the bridge shall safely pass. All right, that the bridge shall safely pass. So we can say in this phase we understand about the water coming to the bridge. So in hydrological design, we estimate flood discharge that the bridge shall safely pass, and it assesses also all the water that is going to come to the bridge site where we are proposing to construct it. All right, and it answers questions like the hydrological design of the bridges. It answers questions like 1. How much rainfall occurs in the catchment? How much rainfall occurs at the catchment area of that particular bridge site? All right. So what is catchment? The upstream area from the bridge site which contributes to the water of the river is known as its catchment area. So the first answer that this hydrological design provides us, that is, it gives us the amount of rainfall which occurs at the catchment area of that particular bridge site. Second one being how much runoff will reach the river. That is very important. How much runoff will reach the river where we are proposing to construct our bridge. All right. The first answer it gives us is the estimation of the rainfall that occurs in the catchment. The second one being how much runoff, very important, how much runoff will reach the river or the bridge site. Third one being what is the design flood. For example, the 50-year flood, the 100-year flood, etc. All right. So the hydrological design deals with the estimation of the flood discharge that the bridge shall safely pass, and it makes an estimation of the water coming to the bridge site, and it answers questions like how much rainfall occurs in the catchment, how much runoff will reach the river, and what is the design flood, that is the 50-year flood or the 100-year flood. Now we shall study about the main aspects of the hydrological design of bridges. Let me rub it first. Will be also solving as many numericals as possible after completion of each and every topic, like we do during all our topics. All right. So the main aspects of the hydrological design of the bridges are: 1 being the catchment area analysis. catchment area analysis. All right, already discussed how much amount of rainfall occurs in the catchment of that particular bridge site. Second one being rainfall intensity, duration, frequency, all right, etc. This is the main aspect of the hydrological design of the bridges, that it tells us about the rainfall intensity, duration, frequency, etc. Third one being runoff estimation, very, very important. Runoff estimation, because that is the water that is going to come to that bridge site. Runoff estimation, we can do it by rational method or the unit hydrograph method. All right, etc. So this is also main aspect of the hydrological design, that it gives us the runoff estimation. Fine. Peak flood discharge. Peak flood discharge. That is what we are interested in as the designers, that we have to estimate for the peak flood discharge. All right. So that is the main aspect of our hydrological design of bridges. Fifth one being return period. All right, return period of the floods as per IRC or IS codes. So the very output of hydrological design of bridges is that it gives us the design discharge. This all work is being done just to estimate for this particular thing, which is the design discharge. All right, in CUMEC or any other unit. All right, as per our requirements, meter cube per second. All right, so the main objective of the hydrological design is to arrive at the design discharge. All right, moving on to the hydraulic design. Now that we know that how much of discharge is, or how much of water is going to come to the bridge site, we have to study the behavior of this water, that how it will pass under the bridge and how shall we design our bridge accordingly. All right, let me rub it first. Hydraulic design. Hydraulic design of the bridges. All right, so in hydraulic design we study about how this water will flow under the bridge. We know how much of water is going to come on that bridge site. We have made the hydrological design. Now how the water will flow under the bridge. That part is being dealt in hydraulic design. So in hydraulic design, it uses the design discharge from hydrology, which we have already calculated. All right, design discharge. It uses the design discharge from the hydrology or the hydrological design to design the waterway and other bridge components. All right. It answers questions like, let me summarize them one by one for you. It answers questions like, how wide should the bridge opening be? How wide should the bridge opening be? Second one, what will be the water level during floods? Very important. What will be the water level during floods? It also answers questions like, will there be a flux or the rise in water level? And also, is the velocity safe against scour? All right, so these are some of the questions which the hydraulic design of bridges answers us. And the main aspects of this design is, let me drop it first and write it down for you. It answers questions like how wide the bridge opening should be, what will be the water level during floods, will there be any rise in the water level or afflux, and is the velocity safe against scour? All right, and the main aspects of the hydraulic design of bridges is, let me write it down for you. Number 1, waterway width and opening. Waterway width and its opening. It is the main aspect of the hydraulic design of the bridges. The second one being the flood level, or the HFL as you commonly call it. All right. Third one, afflux calculation. Fourth one, the flow velocity. Fifth one, scour depth and foundation depth. Sixth one, design of piers, abutments and protection works. Design of piers, piers or piers, howsoever you may like to pronounce them. Piers, abutments and protection works, like that of riprap, launching apron, etc. All right. So these are some of the main aspects of the hydraulic design of bridges, that it tells us about the waterway width and opening, the flood level or the HFL, the afflux calculations, the flow velocity, the scour depth and foundation depths, design of piers, abutments and protection works. So the output of hydraulic design is just like the output of hydrological design was peak discharge. The output of hydraulic design is, let me rub it first. The output is water levels, velocities, scour depth, and foundation requirements. Foundation requirements. So this is the output of the hydraulic design of the bridges, that we come to know about the water levels, the velocities, the scour depth, and foundation requirements. And the output of this hydrological design was design discharge, or the peak discharge. All right. Fine. So this was about the hydrological and the hydraulic design of bridges. What we do, what are their aspects, and what is the outcome of doing such designs. All right. We'll move to next subtopic, that is importance of hydraulic factors in bridge design. All right. Importance of hydraulic factors. Importance of hydraulic factors in bridge design. All right. See, the process of arriving at a final design of a bridge is very elaborate and complex. It involves a lot of geotechnical, hydraulic, and structural attributes. All right. And these attributes are adjusted in such a way that they satisfy the functional, the economical, and the aesthetical constraints. During design of bridges, we are bound by certain factors, one being its functionality, second being the economics, and third one being the aesthetics, all right? And the process of arriving at a final design of bridges is very elaborate, it's very complex, it involves a lot of geotechnical, hydraulic, and the structural attributes. And our topic for this video lecture is the hydraulic design, all right? So the hydraulic parameters which influence the sequential phases of a bridge design can be summarized in certain phases, and we'll be taking them one by one. Phase number one. We are discussing about the hydraulic parameters which influence the sequential phases of hydraulic design of the bridges. Now we have summarized or categorized them in certain phases, and we'll be taking one by one. So the phase first. During this phase, site reconnaissance, review, and analysis of available river data are undertaken. Site reconnaissance, and the review and analysis of available river data are undertaken. During phase first, we do the site reconnaissance and we review and analyze the available river data with a view. What is our objective? With a view to selecting possible bridge locations that are compatible with the proposed communication route. All right, our motto, our objective is to select possible bridge location out of many choices that is compatible with the proposed communication route. All right. So during phase first, we do the site reconnaissance, we do the analysis of the river data with a view to select a possible bridge location that is compatible with the proposed communication route. So this is the phase first of the hydraulic parameter analysis to carry our generalized hydrological and the hydraulic design of the bridges. Let me rub it first so that we can move to phase second. All right, phase second. Phase second. At each of the possible bridge sites, the hydrographic and hydraulic surveys are conducted. All right. the hydrographic and hydraulic surveys are conducted at all possible bridge sites. So in phase first, we do a site reconnaissance and with a view to select a possible bridge location that is compatible with the proposed communication route. All right. And in phase second, at each of the possible bridge sites, we conduct the hydrographic and hydraulic surveys. Very important. In phase second, we do these surveys at all possible bridge locations which are compatible with the proposed communication route. Phase third. From the available data, we study about some of the hydraulic parameters. I'll write them one by one for you. The first one being maximum flood flow. Maximum flood flow. Since we had our data from the phase second, we have the hydrographic data, the hydraulic data, because we have conducted the surveys. Now from those surveys, from that data, we assess certain hydraulic parameters. The first one being the maximum flood flow. Second one being the design flood flow. Third one being maximum flood level. Fourth one being navigational requirements, very important. This is a very important hydraulic parameter. Next one, bed and the bank characteristics. That is also very important hydraulic parameter. We have to assess about the bed and the bank characteristics on that possible bridge site or the location. Sixth one being approach velocity and direction. Very important. Approach velocity and direction. Seventh one being the flood plain width. Very important. Flood plain width. And the last one being the river meandering characteristics. We have to take note of that also. River meandering characteristics. All right. So these are some of the hydraulic parameters which we have to assess, and we take them in the phase third of our design. All right. And some of them being the maximum flood flow, the design flood flow, the maximum flood level, the navigational requirements, the bed and bank characteristics, the approach velocity and its direction, floodplain width, and the river meandering characteristics. All right, then we'll move to the phase fourth. Let me rub it first. These are the phases of our design. The hydrological and the hydraulic design of all the bridge structures. As already discussed, it's very important to take note of the characteristics of the river beneath where we are proposing to construct our bridge. And all these exercises are being made for that particular thing only. All right, so let's move to phase 4. All right, phase 4th. During this phase, linear waterway, normal scour depth, afflux, backwater effect, flow velocity, including the works requirement for a suitable river training scheme are evaluated or determined. I write them for you. During phase 4, linear waterway, normal scour depth, afflux, backwater effect, flow velocity, including the work requirements for certain river training works. These are all determined or evaluated during phase 4. All right. So we determine the linear waterway, the normal scour depth, the afflux, the backwater effect, the flow velocity, and the river training works as required at that possible bridge location. All right. So this forms the phase 4th of our bridge designing. All right. Moving on, we'll go to the phase 5th now. Let me drop it first. All right. So phase 5th. During this phase, various alternative methods of construction taking into account the factors such as structural loading, the soil characteristics, the economy of construction. This is the very important phase, phase 5th. The economy of construction, the availability of manpower, both skilled as well as unskilled, availability of manpower, access to the site, prevailing climate factors, / environmental impact, and most importantly, maintenance are considered. All right. So in phase 5th, we take various alternative methods of construction into account, such as first one being the structural loading, the soil characteristics, the economy of construction, the availability of manpower, the access to the site, the prevailing climate factors or the environmental impact, and most importantly, the maintenance is considered. All right. So this forms the phase 5th. And also in addition to this, during this phase, we also assess for some other factors of the design of the hydrological and the hydraulic design of bridges that I'll also write it down here. We also make detailed investigation of certain other factors which affect the configuration of the bridge in this stage, and those being, number 1, proper freeboard, very important as far as the hydrological or the hydraulic design of bridges is considered, proper freeboard. Next one, vertical clearance, very important. See how important is this phase, the hydrological and hydraulic design of bridges. We get to know about the core factors or the parameters which, on which our bridge designing is based. Third one being the height of the bridge. Height of the bridge. All right. And hydrodynamic forces on the pier. All right. So during this phase, we make detailed investigation of certain other factors which very importantly affect our configuration of the bridge, and they are: we assess for proper freeboard, vertical clearance, height of the bridge, and hydrodynamic forces on the pier during this phase. Due consideration is also given to the proper location and the geometry of the piers. Proper location during this phase and geometry of the piers is also given due consideration. Our motto should be: the geometry of the pier should be such as to minimize the backwater effect and scour. All right, that's very important. And most importantly also, the pier should be aligned with the principal direction of flow so that the streamlined flow is maintained. For that, the pier should be aligned with the principal direction of the flow. So this was all about the phase 5th, very important phase as far as our hydraulic design of bridges is considered. Very important phase. Moving on to phase number 6. I'm summarizing all these hydraulic parameters phase by phase. And now we have to study what do we do during phase number 6. All right. For the proposed configuration of the bridge, normal scour, maximum scour, and backwater effect are computed. Normal scour, maximum scour, and backwater effect are computed or determined. All right, so this all is being done during phase number 6. Moving on. Phase 7. Now we come over to the phase 7, and during this phase, the cost of alternative schemes for each location is appraised in this phase. All right, so if the cost of the scheme is outside that of the budgetary constraints, savings may be possible by altering the designs. All right. So during phase number 7, the cost of alternative schemes for each of the location is appraised. And if the cost of the scheme is outside the budgetary constraints, all right, so then we can also do savings. How? By altering the designs. Now we come to the last phase, that is the phase number 8. All right. So this is the last phase of our designing of or assessing of the hydraulic parameters of the bridge. So after studying the alternative bridge designs for each of the possible bridge locations, the best scheme is selected for the detailed design, and based on the recommendations, a decision to verify the hydraulic parameters by model investigations is also considered during this phase. All right. All right, so in phase number 8, after we have studied the alternative bridge designs for each of the bridge locations, we have to select the best possible scheme for detailed design during this phase, and if possible, or if based on the recommendations, a decision to verify these hydraulic parameters which we have assessed during all the phases, we can go for model investigations. That is also considered during this phase. So this was phase-wise summary of our hydrological and the hydraulic design of bridges.